would be talking about reshaping the data and joining tables. For today's presentation, what I have in mind is to talk about reshaping the data, merging the data and comparing the data, which is the essential thing for tidying up our data, how our data looks like and how we are that will help us analyze the data better. So for today's presentation, we will explore about pivoting the data, making it wider or longer, looking at different types of joints and some set operations. So just to dive into the demo script, is this visible for everyone?
Yes.
Yes.
Thank you. So for the demonstration purpose, I'm using this library NYC Flights 13, and I will be using the flights dataset for the demonstration purpose. So let's get started by loading the required libraries, and then let us look at how the structure of the flights dataset looks like. So here, as you can see, that this is a very big dataset which has like 19 different columns and around 300,000, more than 300,000 rows. So like to understand more about this data or how we can play with this particular data set, first we will start by reshaping the data, trying to like widen the data or like make it longer so that we can work on it. Just as we can, here we have like we can look at the delays by month for each of the carrier. So we can look at the flights and filter it by arrival delay, which do not have any NA values, and then group these by month and carrier because we just want to look at the monthly delays. So we want which carriers are getting delayed. So month and carrier, and then just summarize the data. So how this kind of would look like is a table of like 185 columns and 185 rows and three columns, month, carrier, and average delay for this. So say we just like shortened our data. This is kind of a long format. For each row, we have like a month and a carrier and an average delay. Then how this can be transformed into a wider part where we want to see more information. We want a table which has one row per month and then the column per carrier's average. So pivot wider is the function for that used in the tidyverse. So we can just look at how this will just transform our data. So this will give us columns like month for each month, the different types of carriers on the for each of the columns, and then we have this information. Now, say we don't want to look at this wide of a data, we just want to condense it back. So that's the reverse operation, which is the pivot longer. So in this, we are using this wide form of the data and then applying the pivot longer function on it. So here we don't want the columns, we want the names to be the carrier and values to be the average delay. So this is how our data will be transformed back to how it was looking, kind of having three columns and 192 rows over here. So this is about like widening the data or making it to a longer format. So these two functions, pivot wider and pivot longer. Then another, like moving on to the next function to reshape our data, is there's a function called as separate. So let us like take an example of how the date time in the flights data set looks like. So we can select the time hour column and then just look at head of it, like slice it, looking at the first 5 representations, and then we can make it as a character for that. So this looks like we have a table. So this is the original date time column which was there. Here you can see the type of this particular column is the date time, and then we just like transformed it to a character by as character, making this particular column as a character, and then now applying separate, which will like split this particular column. Say we want it to be separate as like time and date. So then we have this character column, and then we want to separate it into date and time by just like a space separator. So then applying this separate function on this data would look like we have these new columns, date and time, this is what we had separated the time hour column into date and time. So we have these columns as characters because we had transformed our time hour column into character. And then this will give us separate it into these different columns. Now, since we have like a separate column, we can also unite different columns together. Suppose let us look at these different columns in the flights data set. Say this is like year, month, and date and day. So this is how this looks like. And then we want to unite this particular columns together so that we have the date as together. So we want them to be together in a column named as date. By the format we want is year, month, and day. And then we want to separate it by hyphen or a dash. So then applying this unite function, our data would look like this way. So you can notice like it just like combines it together. But if we want to make it a little bit more pretty, we can just like add some zeros to our date and month because it can go from 1 to 12. So if we want to, which can like padding zeros can help us like arrange our data in like ascending and descending order so that we don't run into any error in future. So we can like this sprintf will just like pad zeros to how many zeros we want to, so that our date and month should have like 2 digits. So we are telling that if it is how many zeros it should add. So the difference would look like this. So this looks much better. So with this unite function, you can also like just arrange our data. Like we are creating another column where we have these nicely pretty looking values in that. So this is how these reshaping functions would look like. So just in summary, we kind of looked at the pivot wider and pivot longer functions, which makes our data into longer or into transforms it into a wider format. And then separate is like splitting one column into multiple columns by whatever separator you're giving it, maybe a space or a dash. And then unite function is the opposite, is the reverse of that, which combines multiple columns into one column. And again, you can join those multiple columns together by a separator. Just in the date and time case, we did it by joining by dash. This was about reshaping. Next, what I have is about joining the tables. So for this, I am going to look at the flight level data and another data, which is airlines data. In this, it has the carrier codes and full names. So because we want to join 2 different tables, so this is the second table that I'm going to look at. Just let us take a look how this airlines looks like. So this has a carrier column, which has the codes, carrier codes for each of the airlines, and another column which has the full form of these carrier flights. So for the flights data, we can maybe just select a few columns. Say we want to select year, month, day, the carrier of the carrier, and the flight. So this will kind of look like we have the year, we have the different months, date, and the carrier code and the flight number in this. Now for joining tables, there are different types of joins. So in joins, there are ways that you add different tables together just by adding. So that is like, this is called as mutating. So the next few examples I will show is related to mutating, where we join the columns from 2 different tables, like from another table to the original one. And there is another which type of joins which come under the category of filtering, that I will also show after these examples. So in mutating, like adding, which is like joining the columns from another table. So the first type of join is the inner join. So this basically keeps only the rows that have matching keys in both the tables. For example, we have the flights. We have selected these columns: year, month, day, carrier, and flight. And also in the airlines, we have a common column, which is the carrier. So in the inner join, like this example, we can say that to this bigger table, we want to join the airlines table. So how we are going to join, how it will know that it should join is by giving it common column name. So here inner join by the inner join adding that is joining by the other table airlines, and you give it argument by, and this we are by joining by carrier. So this will kind of look like so we joined by the carrier, and now you can see this the name column from the airlines has been joined next to the columns table from the flight table. So these were the initial ones from the flight, the columns that we selected, and this one is the appended one. So this inner join is joining by the carrier, but this will only keep the flights with carriers that are present in the airlines, and then those names would be added. But say if you don't give it by carrier, it won't know what like how to add, so that will just kind of run into an error case. So because here it does not know by what common column it should join by. Then next we have is a left join example. So here in left join, it keeps all the rows from the left table and adds the matching columns from the right one. And if at all there are some missing entries, it will fill it by NA. So like again, similar format. Here the important factor is to tell the left join that by the common column that is by carrier. So this will also look like this. Since these both have similar columns, probably if we check if there are any NAs, it says it does not have any NAs. So just to understand the difference, how this works, we can maybe add some extra carriers. So here I'm just like adding some different carriers, just like for the representation purpose, just some extra things. And now if we use, instead of flights data, if I use the flights extra, let us take a look at how this look like. So this has these additional carriers like ZZ, XX, these are the extra ones. And then if we try to left join with the airlines by carrier with this flights extra table, this will look like. So if you see the extra carriers that we had added, so it just like in the names, because the airlines does not have information, it just adds NA to this. So this is how the left join looks like. Probably like when you're working with your data, maybe either you can like remove the NAs or maybe replace it with some name, like whatever is suitable. So in this case, say in the flights extra, we want to replace this particular NAs by unknown carrier that is not present in the airlines data set. So this will kind of replace. And then this will look like, so the NAs are replaced by unknown carriers. And we looked at inner join, left join, and then there is also another one, which is right join. So left join, it joins by the columns, while the right join, it keeps all the rows from the right table and adds the matching columns from the left. So what this means is we are looking at this flights extra because we have these NAs present. So it will be kind of better representation, I guess. So here again, the format is similar. Here we are telling right join by the carrier. So here like it joins by the rows and it keeps all the rows from the right table and then adds the matching columns. So the information which it did not have, it just added NAs to those carriers in the right join example. So like all the airlines are kept, like even if no flights for that particular carrier are mentioned, airlines. This was what the airlines are there, which is the carrier names. And then it kept all the airlines it kept, but the flights which did not have the carrier, for that carrier information was not there, it it adds NAs to that. And then if we have this flights example here, we won't see any NAs because those were the matching information that it had. So this is the example. Then now just to get an overview of the how the whole, if we want to merge the full data sets, the flights extra and airlines data set, there is another kind of join called as the full join, where it keeps all the rows from both the tables, and then it will fill it with NAs wherever there is no match. So format being similar for the full join as well, that you should mention by which column you want to add it, join it. So here it looks like, so here by it added, like it is basically a combination of, it looks like a combination of right join and left join. So here we have some rows where it did not have the information, the carrier did not have any information, so those rows have been filled by NAs, and also the names for the carriers which the airlines did not include, those columns, those are added with NAs. So this is how this inner join, left join, right join, full join functions look like. This was about combining the columns, two different tables together. That is called as mutating. These four are categorized as mutating joins. Then apart from this, there are two other types of joins called as semi-join and anti-join. So here, these joins will do the work of filtering the rows from one table based on the presence or absence in the other. So let us look at the first one, which is the semi-join. So what this will do is, this will just keep the rows in the flights table where the carriers exist in the airlines. So because we had this in the flights extra, we had added some dummy carriers, so we can see let us look how it will. So here you see that this is just a table with three rows and 5 columns. So basically it just keeps the information with the carriers, keeps the rows in the flights where the carriers exist in the airlines. Here you do not see any NAs, just where there is a overlap between the two carriers, it will keep just those. And the anti-join, it will give us the information where the carrier does not exist. So where we want to see distinct carriers, so this will give us the information about which carriers are different. So this was the extra carriers we had added in our flight extra example. So this is how this example looks like. Again, if we were using the flights data set where we did not add these extra ones, then in that case, this won't return any value. This will be empty because all the carriers were present in the flight and airlines, they match. So this is how these joins also work. Now we looked at some functions which were present in the joins functions from the tidyverse, but we can also compare it with the base functions. So I have these few examples how these work like. So if we have these data frames for flight and airlines, for the inner join, and so for the inner join, the function that is present in the base R, it uses the merge function. So one thing to be careful with using this merge function is how we passing the argument. So for the inner join, we are just telling that it should add by the carrier column. So the inner join will just give us all the columns, all the data which the flights and airlines data frames have. But then now with the left join, the difference is by we want all X. So this is the difference between using for the left join and the right join. So all Y and all X. So the left join, this is how the left merge would look like. And then if we do for the right join, so we want all the columns. So then these are merged, keeping all Y. And then the full merge is you give the argument you want all true. So this is how the difference would look like in the full merge. But these tidy was joins, these easy to use by just like the kind of arguments that we give, and also like better with complex type of data. So like this is how the joins would work like. Next I have is about binding the data. So there are these two functions, bind rows and bind columns. So by bind, we are binding the rows, that is stacking the different data sets with same columns. So maybe we can look at the example where we have these data from the flight, we are filtering it by the month. So here the month that we see is the first month for January and February. And then we want to bind these two by the rows, by binding the rows. So we give it the information like the arguments as flights January and flights February. And then we can see that these, like we had these 5 from January and 5 from entries from February. So now we have the 10 entries together. So this is joining by like binding by the rows. And the important thing is that these have the similar columns together, so that then these it can you can bind the rows. Next, so this, like if we add some extra column just to see how it will work. If we try to bind the rows where there is mismatch in the columns. So flights in January and then flights January extra, which has like an extra column. This looks like this extra column just basically had nothing in it. So the thing is that these binding rows will just work for that. And then similarly for the columns, we are selecting these different columns. Say in data frame 1 and 2, we are selecting different columns from flights January. And then we try one has these three columns, year, month, and day. And DF2 has carrier, flight, and tail number. So if we want to bind these columns, so bind columns basically will just bind these different tables together. And then if we want to compare how these functions are different from those in base R uses R bind and C bind. So say if we want to see the example, similar to using the bind rows, this you give it a argument as flights January and flights February. This will have similar results. But if we want to bind by rows which has differing columns, so if we try to do that, this will throw an error. But this will not tell us that this is binding by bind rows, will not tell us that, give us an error. But if we check, we can see that there are some NAs because extra column had NAs in that. Next, I want to show the example of C bind. So here C bind is similar to how the bind columns works like. So this, if we C bind data frame 1 and 2, this does the similar work as bind columns. But suppose we have a different length of the columns. So in that case, if we make like shorter data frame which just has 3 entries from the flights January, and we try to match these, it will, with C bind, this will give us an error. And like even bind columns will also give us an error. But I want to just draw an attention that the if like how the working of C bind and bind columns differs is, say we have a simple example where we have A equal to 1 to 5, and we want to bind by these two arguments. What this will do is, so even though A and B had different lengths, this will just recycle after 1, 2, 3, 4, 5. This is A, and then the B column after 1, 2, 3, it will recycle the values, and instead of like adding NAs or giving an error, it will recycle those values with warning message. But for the bind columns, if we try to run the similar way, this will give us an error saying that there is a size mismatch. So this is what I had in the joins part. Next, I have is some set operators. So set operators, like whether the two data sets that we have, they intersect, or we want to find the unique values in both of them, or we want to find a difference between them. So these set operators are useful in that case. So for the demonstration purpose here, if we create like small examples where, say, flights one, we are filtering it by month, like the first month, and say we just want to look at 10 entries, and then select the columns year, month, day, carrier, and flight. And flights two is basically the day less than greater than 5, but less than 15. So how these, so this is just like the days that differing, which has like around 8,000 rows, and this one has around 9,000 rows. And say we want to intersect, we want to find the rows that are common to both these. So how this function works is, we just give the input arguments as flights one and flights two in the intersect function. So this will tell us that there are around 5,000 rows which are common to both. So that is how the intersect works like. Then in the union table, this will tell us this won't the entries which are similar, it won't repeat those, that would be counted just once. So around there are unique in both, combining both the data sets, there are around, if we look at this, there are 13,000 rows. And just if we want to look at the difference between the two data sets, there is a function called as set difference. So this will basically tell us that around 3,500, 3,600 rows entries are different between the two data sets. And we want to see if both these are equal. So these are not, because as we see that if we look at the difference, we have so many, like 3,000 different rows. So set equal basically will return a false value in this case. So these were the examples. I know a lot of different functions we looked at. Just to summarize what we looked at the pivot wider, pivot longer, which is like collapsing the multiple columns into together. We want to spread the data. Then we have separate and unite functions, which splits one column into multiple by the separator of your choice. And then unite is the reverse of that, which combines the multiple columns into one column. And then this is a summary, as we saw different examples about the left join. So it basically like mutating join and filtering join. So under the mutating join, left join, right join, inner join, and full join, we have these functions. So here joins by matching the values from y to x. If we have like the ones on the left to right, the x and y. So this is joining the values. And then the right ones is by join by matching the values from the x to the y. If there are any differences, you will see on here you can see the NA difference. And then the inner join will just retain the rows which have matches. And full join is joining, retaining all the values and all the rows. And filtering is filtering joins. This is by semi-join and anti-joins. So semi-joins tell us about what values, what rows match, whereas anti-join gives us the ones which are not included in the join. And then in the set operations, we looked at intersect, set difference, and union. So intersect basically gives us which appear in both the data sets or the tables. And then set difference tells us about the rows that appear in X but not in Y, depending on how you are giving the values here. And union is basically telling all the unique values to both the data set. And then set equal tells us if whether the two data sets have the same rows in like same order or not. So this is what I had for today's presentation.